I've been amazed throughout my career at the number of engineers that are brilliant engineers, but can't explain a concept. They can't tell the story that they need to tell to get people interested in what they're talking about. Engineers have a tendency to just go straight to the math, straight to the data, straight to the graph, and you have to get the listener to be invested in what you're saying. If you can get them interested in what you're saying, you can get the graphs in and the math and everything else in there, and they'll put up with that. But you got to kind of tell a story to make them get involved. And when you can do that, I think it's interesting.
Welcome to the Feria TechCast, where we'll bring you all things science, engineering, technology, and innovation. Today, we're joined by Dave Cole, software engineer, Facebook data center architect, and creator of the Math Kids book series that makes mathematics an adventure. Dave's journey spans from teaching college computer science to designing critical infrastructure at Facebook, with a career that includes founding two successful tech companies. What makes his story unique is how he's taken that technical expertise, including early work on designing missile guidance systems, and channeled it into creating children's books that brings math to life. Through his 12-book Math Kids series and nationwide school visits, Dave shows young readers how mathematical thinking solves real-world problems. So, Dave, welcome to the show.
Thank you very much. It's great to be here.
All right. So, walk us through your wild career shift from building data center tools at places like MRC and Facebook to starting your own companies like No Limit Software.
I think it was taking an idea. I like to build things. As an engineer, like most engineers, I like to build things, whether it's software or hardware or firmware, whatever it is. That process of coming up with something new. And I was working for a company that designed software that monitored some of the equipment in the data center, particularly uninterruptible power supplies, UPSs. And to me, it should have been a broader piece of software because there's other equipment. So I need to monitor not only UPSs, but power distribution units, environmental, all kinds of things, cooling units, and so on. So I expanded that concept out, started a company called the Advantage Group to build commercial software to manage everything inside the data center.
Okay, so what kicked off your love for tech and math early on? Was there a gadget problem or a moment that you got hooked on, like that made you got hooked on things like missile guidance system in your first engineering roles?
I can probably go all the way back. I was probably 8 years old or so, third grade, and I had a teacher, and I was very good at math. I could always do math really well, but I never did any of the homework because I didn't see the need to do homework. I knew how to do the problems, and my teacher did not see it that way. So she solved the problem by actually giving me more and more difficult work to do. And a lot of it was in the form of puzzles, some of the classic puzzles, and I loved it. And even though it ended up I was doing a lot more work than the rest of the kids in class, I didn't care because I was loving what I was doing. So she kind of inspired me to go above and beyond and solve problems. And engineering is about solving problems. Math is about solving problems. There's a lot of math concepts I think that apply to all kinds of other areas of our lives. So I think that's probably how I got my start.
So, what's the biggest aha moments that made you pushed or that pushed you into entrepreneurship?
I was working for a small company at the time, and um, it was interesting. I saw how many things they were doing wrong, and I said, "I probably could do this better myself." And, that company got bought out by another company, and, that was kind of my opportunity. I said, "If I'm gonna do it, this is probably the time to do it." And I started with just 4 people, um, got some early contracts in with, a couple of, big companies, and then we got some work in from Hewlett-Packard and some other things, and the company just kind of grew. So, we did some consulting work, and we also did some of our own product development, and, I was just loving to build things, build my own things. We put some patents in on some things, and it was just fun. It was a lot of young engineers that were just having fun. We didn't realize we were probably working too hard and not taking enough vacations and doing things like that because it didn't really even feel like a job. We were having so much fun.
Interesting. So, you've gone from high-tech industry leader to full-time author and math coach. So, what exactly sparked that switch for you?
I was kind of doing both. I during the summer times, I was running an elementary school math camp for probably third to sixth grade students. And my son actually got me started doing that. He actually started the camp and he needed an adult. He was in high school at the time. He needed an adult to be able to rent the buildings and do things like that. So I started doing it with him. Then he went off to college, and I kept doing it because I enjoyed it so much, and I thought it was important. I think kids are kind of shying away from math, and you need that math to be able to do everything beyond math, to do physics, to do a lot of the hard sciences, to do computer science, and really to do a lot of things because, like I tell kids when I go and visit schools, math isn't just about solving computational problems. It's about the logic about solving any kind of problem. What is the approach we take to solve a problem? And when they look at it like that, I think they understand that it's more. So I was doing that. Started coaching some elementary school math teams as a result of that. Enjoyed doing that, and in one of those camps, one of the kids said, I told a lot of stories to teach concepts. Um, I think it works particularly well for elementary school kids, but I think it works for adults and it works across the board. It's more interesting if you're telling me a story than if you're just, showing me something or showing me a graph or just some data. So I would tell stories to get across these math concepts. And one of the kids said, "You these would be great books. Your stories would be great books." So I wrote the first three. I was working for Facebook at the time. Had some free time on weekends, and I said, "I'll give this a try." So I wrote the first three books. I sent them to a publisher. She said, "We love these. Can I get some more?" And so I signed a contract for the first three books, then the next three, the next three, the next three. Then I did a younger kids version of those kind of same stories. So it just kind of rolled out. I think we've been translated now into 9 languages, and the books are sold all around the world. So I'm kind of an accidental author, I guess.
That's interesting. Could you tell us, I mean, like, list the languages that you can remember off your head that your book has been translated into?
Yeah, the first one, surprisingly enough, was into Mongolian. Um, and the my publisher worked with a company that gets books into other countries, and had been at some book fair, and a publisher from Mongolia said these would be interesting. And then we went from there to, I believe, South Korea was the next one. That was kind of a big one because they bought a lot of copies of the book. They're very popular in South Korea. Um, Simplified Chinese, so in China, Turkey, um, uh, French and Spanish. I'm missing something big. They're in India, but in English. And Romania was the last one that we just signed a deal for. So it's been interesting, and I'll get the covers in. and of course, it's in a language I do not speak. So I can look at the books, but I can't actually tell what they say. And it was interesting because I was out at a elementary school, and I brought the South Korean books with me to kind of show the kids what they look like. And I said, "Does anyone speak Korean?" And one little girl raised her hand, and she said, "I do." And I said, "So what does this say?" And she looked at the book. She goes, "Well, it doesn't say the math kids," which is what the American title is. I said, "What does it say?" She says it's called the Math Detectives. So the Korean versions actually changed the title of the series, but they bought a lot, so they can call it whatever they want, I guess.
Yeah. So tell us about your book, The Math Kids, and the inspiration behind the kids in the book.
So each book has a kind of a math concept. So I start each book with some kind of some kind of math that I want them to learn without them knowing they're learning it. So the first book is called The Primetime Burglars, and they end up solving the mystery. Little spoiler alert, using some prime numbers, and that's how they kind of figure out what's going on. So then I can kind of talk about prime numbers a little bit, and so each book has some kind of mathematical concept. One talks about the Fibonacci sequence. One is talking about pi, and so on. So it gives me a way to kind of put some concepts together, math concepts together. And if the kids are just interested in the mystery, they may not care about the math. So I don't, it's not a textbook. There's still mystery stories. I want the kids to read the stories. If they get a little math in, which they probably don't even know they are, all the better. So each book kind of goes around some concept, and I find a mystery that concept will help them solve.
All right. So I've seen somewhere where you wrote that you call math the overlooked M in STEM. So what's one surprising way math is more exciting than people actually realize?
I think, especially when I go out to elementary schools, if you think about when we're doing early math, we're adding, we're subtracting, we're multiplying, we're dividing. There's really nothing very interesting in that. And so I think a lot of kids get bored with math. And when I ask kids, I always ask who likes math and who doesn't like math. And the ones who don't like math, when I ask them why, some I get one of two answers. One is it's hard, but more often I get it's boring, and they're doing the same steps over and over and over again. So what I do is I we do some interactive math, and we do math without any numbers. I'll take a strip of paper, and we'll make Mobius strips, and we'll cut those in half, and they're going, "Wait, why did I when I cut this in half, why did I get just one thing instead of two things?" And they get surprised by math, and I think that's a good thing. I want kids to see that math can be surprising. We also talk about things like the Fibonacci sequence and the number of petals there are on flowers are always going to be a number in this Fibonacci sequence. And we talk about what the shapes that a Fibonacci sequence makes and how that's the same shape as a hurricane or a wave. Um, and they just get amazed that this math is all around us, and I had one little girl write me the nicest note. She said, "I didn't really like math before you came out and talked to us. And now I see that I was missing a lot of things. And now I'm going to give math another shot." And I said, "That's perfect. That's what I wanted you to do."
Interesting, yeah. So, I mean, like the first time I came across the Fibonacci sequence, I myself was really astonished to find out that, I mean, these mathematical patterns present in itself in very, very broad areas of nature, and I mean, the world we live in generally. So, yeah, I think that's a really interesting way to catch a kid's attention and break it into mathematics. So, tell us, or better still, let's say, give us some of your secrets to getting kids to become more interested in maths. Of course, you talked about, this Fibonacci sequence and the story you just mentioned, but I'd like to hear more on it.
Yeah, I do. I tell lots and lots of stories, and anything we're doing, I can come up with a story or a game around the concept. And I'll give you an example. We were running this math camp, and my son really wanted to talk about supply and demand, right? An economic concept, but also mathematical. So we ended up playing. It was a kind of a tag game. Some of the some of the kids were assigned the role of they were like some like a rabbit or something like that. Others were assigned the role of a coyote, something that would eat a rabbit, and something else. Some of the other kids were assigned a role of something that would eat a coyote. So we had them go out and coyotes could only go after rabbits, and lions could only go after coyotes, and some animals could go after anything. And then we started limiting the supply. So if I put less rabbits out there, the coyotes didn't get enough to eat. And if you didn't get enough to eat, then you starved. So we just played this tag game for probably an hour, and the kids were having fun. And then we came back in, and I said, "What happens when there weren't enough rabbits?" And they grasp the concept of supply and demand because, oh, if I don't have enough of this, then I need this. And it was just a really good way of interactively presenting them a concept that if I just gave them formulas and things like that, I don't think they would have been interested. But when we made it active and when we kind of showed them some real life situations, I think that really helped. And I think anytime you can show them something that feels more real life to them and not just numbers on paper, I think they're more apt to be interested. And if they're interested, they'll want to learn more.
That's a really, really, really great secret to turn a boring math lecture into an adventure. Yeah.
Right.
So,
One of the one of the time and I am not a very handy person as a mechanical engineering, and part of my background, I should be better at like building things. It turned out I was better at software and math, but I built a mechanical computer out of wood, and I made flip flops out of wood, and metal balls will go down, and this thing can add, and it can multiply, it can count, and the kids love watching the balls go through there, but they get the concept that, oh, this register went from 0 to 1, but now the next time a ball comes through, it's going to change that register from 1 back to 0, but then it's going to do the next register from 0 to 1. And they actually see kind of mechanically how a computer works. And I showed them how a memory overflow would look and things like that. And it was just very visual for them. And that made it it was always a hit whenever I'd get the big computer out. They loved playing with that, and some of them just was balls dropping through. But for other people, they were really grasping the concept, which to me was great.
wow, talk about using your engineering background to make tools that allows students to, better understand mathematical concepts. That's really commendable. So, give us an example of how you would make concept like algebra or geometry sound like an interesting story for students.
Yeah, I think I usually what really gets kids kind of excited is anytime I start talking about patterns, geometric patterns, or all kinds of patterns, because you can relate patterns to things in real life, and then they kind of get that, and kids love playing with patterns, and I've always been fascinated by patterns and sequences and how they came to be. I talk about there's a story about Carl Friedrich Gauss, when he was a young boy, adding the numbers up from 1 to 100 very very quickly, and he did this in about a minute by coming up with a pattern of getting to that number. And the kids are always fascinated by that story. And then we kind of walk through what that is, and depending on the age of the kids, if they're in elementary school, they can be fascinated by the story, and I can show them a way of doing this that elementary school kids can understand. If you're in middle school or high school, now we can look at the algebra and why does the algebra work? Why does that work when we do that? And so it works at a lot of different levels. I've given the same presentation to third graders and high school students and gotten some of the same reactions because it's stuff they just haven't seen before. We've only got a limited amount of time to get through a curriculum, and I think we miss some of the fun stuff in math that kids would maybe get excited about, which is unfortunate.
Hmm. So how do you balance teaching math uh, without making the stories feel like a classroom lesson?
Uh, it, Interactive. The kids have to touch it, have to be part of it. That helps a lot. And I found, and I've gotten better at presenting as I've gotten along. As I've gone along. Same thing in when I would give presentations. I used to give presentations at data center conferences all over the world, and I got better at it. I found out what excited the crowd, what made it more interesting, and same thing with elementary school kids or middle school kids. So you get better at it, and the more interactive, the more I can get kids involved with doing the concept. The more interested they are. Where at the beginning I say, "Who wants to volunteer?" and no hands go up, and at the end they're like wrestling with each other to be the next one to come up. If you can do that, then you've probably done something right.
So was there any unexpected lesson from your experience working in data centers that helped you write or teach better?
Um, I will say it was a good experience working for Facebook or Meta now, just because a lot of the company philosophy on kind of collaborative problem solving. I think that helped. Um, I've been amazed throughout my career at the number of engineers that are brilliant engineers but can't explain a concept. They can't tell the story that they need to tell to get people interested in what they're talking about. Engineers have a tendency to just go straight to the math, straight to the data, straight to the graph, and you have to get the listener to be invested in what you're saying. If you can get them interested in what you're saying, you can get the graphs in and the math and everything else in there, and they'll put up with that. But you got to kind of tell a story to make them get involved. And when you can do that, um, uh, I think it's interesting. And I'll give you an example. I gave a presentation at it was a data center conference um, a number of years ago, and my daughter had just come back from I think she was in Malawi, Africa. She was working with an NGO that made a peanut butter substance to kind of help fight malnutrition. And she had sent back a lot of pictures and she told me a lot of stories about her experiences over there. I spent probably the first 10 minutes of my presentation at this data center conference showing pictures of her talking about problem solving that she was doing. And some of the problem solving was, how do I get this peanut butter liquid? How do I get it to this village or from here to there? And this bridge is out, and we have to do this. And just some of the stories she had told me. And then I went on to talk about solving data center problems, like for the rest of my talk. And I remember walking through the exhibition hall about 2 days later. Somebody came up and said, "You're the guy whose daughter went to Africa." And I said, "Yeah." And he goes, "That is the best presentation I've ever seen." He goes, "I was on the edge of my seat." And he goes, "And I even put up with the rest of the presentation just because of how you started the story." So I think that's important to get people interested in what you're trying to say, and then say what you want them to hear.
So are there any similarities between running a software company and writing children's book?
Uh, That's an interesting question. Let me think about that. Um, y- I think I use storytelling in a lot of what I do. I use storytelling when I had group meetings and things like that, just to uh, and actually, if you think about it from a software perspective, the software is not what you're selling to somebody. What you're selling is what they get out of the software, right? They don't care that it's what algorithms you're using. They don't care about any of that stuff. How is that going to make my life easier? So I have to talk to my engineers, my software engineers, about this is why we're building this. This is the problem we're trying to solve. So I think it's a little bit of the same concept when I'm starting to write a kid's book. It's like, what's the problem I'm going to have the kids solve? And then how you solve the problem, that's the part that gets turned over to the engineers on how do you solve that. And they may solve it 100 different ways, and I may not care how they solve it as long as they're solving the problem. So I think that's the kind of similarity I would point out. And again, I think that goes beyond software, beyond hardware engineering. I think it's in a lot of our life is how do we tackle a problem, come up with some first of all understanding what is it we're trying to do, and then go off and do it after that.
Interesting. So, you've taught math to high school students through the Bridge program. So, what are the differences between teaching kids and high schoolers? Can the same storytelling techniques be applied?
Yeah, absolutely. In fact, the first summer that I taught at the Bridge program, I said, this is high school. So it's not going to be, I can't use the same approach I used with elementary school kids. And I think I was boring them. The first like three things, I think I was lecturing. I think they're going, it's summertime. I don't want to be here. This guy's talking a bunch of math stuff. And I think I was kind of losing them. So about 4 days into this, I said, I have to change my approach. So I threw away a lot of the lecture material I had and slides and everything else. And I kind of went back to storytelling mode. And I they got a lot more interested. We started, I was giving them some classic puzzles and things like that, where you don't realize there's a lot of heavy duty math underneath this, and you don't know it because you're solving a puzzle that you think is fun. Um, there's a famous puzzle called the Seven Bridges of Königsberg, and it's a classic math problem that's unsolvable. Um, and I have elementary school kids solve this, and then I can talk to them at a very high level why it's not solvable. But with high school students, I can now get into graph theory and all kinds of things on why it's unsolvable, and how they had to invent an entire new area of mathematics to solve this simple little problem. And now it's a story because it was real people walking across those bridges, which still exist today. Um, and that's easier for them to get that than to just say, "Oh, here's graph theory and how graph theory works." So, yeah, I think that was I kind of learned that storytelling works across the ages.
Great. So, you are a mathematics tutor with a background in engineering. So, I'd like to ask, what's one underrated math skill you think everyone looking to go into STEM-related field should master?
Ah, I think just the general skill of problem solving. I think I've been tutoring some kids on this ACT test that they take the math test, and I'll start off. I need to know where they are, and I will give them some kind of simple problems. And what I've noticed is they just want to start punching on the calculator and doing some things. They haven't really thought out how am I going to solve the problem. So I think just general problem solving skills. um, so I've been having them put your calculator down, put your pencil down, just talk to me. Tell me how you're going to solve that problem. What's the approach you're going to take? And I think that's helped. I think they've already gotten better. These girls I've been working with on solving problems. I think we should be doing that very early in elementary school and getting them understanding. A lot of times we don't even know what it is we're trying to solve. I'll see them punch a bunch of buttons on the calculator and they'll come up with a number and they'll say, "Is that it?" I'll say, "I don't know. What is that?" And they'll go, "I don't know." It's like, so you haven't really, what's the question again? Let's go back to the question, figure out what it is we're trying to get. How do we get there? And I say, "Well, before you get here, I need to have this." I said, "Okay, how do we get this?" "Oh, before I can get this, I need that and that." "Okay, how do we get that and that?" And we'll just kind of step backwards through there. And then pretty soon they're taking a nice methodical approach, almost their internal algorithm on how do we solve this problem. And I think that's a skill that in any area of STEM that we need kids to do.
That's a wonderful, wonderful one there. So, tell us, what's one thing that math tutors can do today to make maths more engaging for kids and themselves?
I'm a big fan of some of the classical math problems and math puzzles. I still do them. I have books of math puzzles that I'd like to do because it makes me think a little bit differently. Um, different approaches. I have to try different approaches that I've learned to the same problem. So I give high school students, I give elementary school students, I gave some of my college students when I was teaching computer science. I was giving them the Towers of Hanoi problem. How do I move these disks from here to here in the least number of moves? And I brought in actually towers, and they were moving disks by hand and thinking it out by hand first before they ever touched the keyboard to start putting in code to do it. I think that made them understand the problem better. So I'm a big fan of solving problems, solving puzzles, and talking through what's the approach, what's the algorithm to do. And I just think that gives people a better approach to solving any kind of problem.
I'd like to ask, you know, AI started popping up, I think, in the last few years ago, and a lot of people are using AI. A lot of people are applying AI to their different fields. So, is there any way that your teaching techniques or methods have changed since the advent of AI, being available for everybody to use and consume? I mean, is there any way the advent of AI, being rapidly available, has contributed or made modifications to your teaching techniques?
It probably doesn't hasn't changed how I teach, but it has made me think personally how to view things. Right? There's certain problems I don't need to certain problems I don't need to solve anymore that I really can just ask ChatGPT or pick your AI source to solve. Um, but getting the most out of AI is a skill in itself. Knowing how to ask the question to get the best answer out of any AI tool. And to me, that's kind of going back to what is it we're trying to solve? And if we don't know how to ask that question, then AI is not really going to help us. We can get a lot of stuff out of AI. They're pretty smart systems. I can ask, and it may ask me more questions to kind of hone in on what it is I'm trying to do. But I think to best utilize AI, we still have to know what it is we're trying to solve. Um, so I think my teaching probably is about the same because I'm still trying to get them to that point. What is it we're trying to do? I talk about AI a little bit more with high school students, and a lot of times I'm advising them not to use it until they're at the right point to use it. I said, don't just ask AI to solve this problem for you because then you've learned nothing, right? So um, solve it yourself and then ask, how could AI solve that problem? How would I have asked AI to solve that problem? I said, now you've learned something out of that. How to solve the problem, plus how to use the technology to solve the problem. And maybe next time, maybe you just use AI, maybe not. It's still important to know how to solve the problem. Otherwise, we're trusting AI that the answer they give us is correct without having anything to anything to bounce that off of to say, is it right? There's a lot of times I see kids on the calculator. It's really no different than a calculator. I will see kids punch buttons on the calculator, and I'll say, "What is 2 times 9?" And they'll say it's 4 million. And they'll hold up their calculator because my calculator says 4 million. I said, "But does that make sense? Does that make sense that 2 times 9 is 4 million?" Oh, I guess I must have hit the buttons wrong. So then we'll talk about just having a number sense of kind of how much is it going to be. If you kind of know it should be around 20 and it gives me 19.5, I go, okay, then I probably got it. I probably punched in the right numbers. But if I punch in some numbers and I get 4 million, I should know that's not right. And we need to know the same thing with AI that is it right? Does the answer make any sense?
Interesting. So, I have one more question for you. So I personally like to save this one for the last to ask every guest I interview on this show. So tell us, Dave, what does innovation mean to you and how it relates to your field?
Innovation is important. If I started two companies, right? And I wouldn't have started a company to do what somebody else was already doing. I wouldn't have seen the point of that. And yeah, maybe I could do it a little better than they were doing or so on. But when I started companies, I was trying to do something that hadn't been done before. Some completely unique approach to solving this problem that I saw. And it's interesting. I started two different companies to do data center management tools. And the two companies were completely different because I was solving two completely different problems and we approached it two different ways. And I did it with a lot of the same engineers because I hired a lot of the same guys, came back. I said, I'm starting another company. They said, we're in, let's go do it. This will be great. So innovation to me is what's your unique approach? What's something different that you're bringing to the table? Not the same stuff that you're selling for $2 less, or it's got a shiny blue cover on it instead of a red cover. What are you really bringing to a customer? What are you really bringing to a product that is truly different? And if you can do that, I think people will come and buy or come and use your stuff. And so that's what I always try to do.
Great. So finally, tell us what's the best place for our listeners and audience to contact you, find your books, or maybe invite you to their schools.
Yeah, absolutely. They can go to davecolebooks.com. So it's just DAVECOLE books.com. And it's got all the stuff about school visits and the books and kind of my background and contact information, everything else on there. So, yeah, they'll find out more about me than they would ever want to know.
That's great, sir. It was nice having you on the show. This has been a really interesting conversation.
Yeah, thank you so much. Great questions and, kind of made me think some. So that's a good thing.